Hi viewers, we are final year student studying in Multitech Dr. Rangarajan Dr. Shakuntala Engineering College in Department of ECE. We are doing a project on the topic of analysis of solar cooking thermal images using fuzzy technique in image processing. The project is presented by Vimala R, Rajalakshmi P and Rajapriya G. We are guided by Mr. R. Devanayagam. In this project, we have done a model of box type solar cooker without a reflector. In the box type solar cooker, the food once kept inside cannot be viewed at any stages of cooking. So, the thermal images are to be captured, and for viewing the level of cooking, the thermal images are being processed. We are processing the thermal images using fuzzy technique and MATLAB. Using fuzzy technique, with if-then rule, we are calculating the heat distribution and level of cooking using MATLAB simulation. For capturing thermal images, we have done the experimental setup box of solar cooker. This is made by constructing two boxes, an outer envelope and inner envelope of dimension 72 and 75 respectively. We have used the materials like copper sheet for radiating purpose, plywood and glass wool for plywood and glass wool, and thermocol. The thermocol and glass wool are used for insulation. The box of outer and inner envelope are done using the plywood. The box is approximately done around 1 × 1 meter. The thermal images we have captured using this camera, visual IR camera. These are some of the sample of thermal images captured by us using a visual IR camera. These thermal images are taken from various food items. These are the thermal images that we are taken from chicken. These thermal images are processed in MATLAB. This image represents the food item that is taken before it is cooked, and this is the image that is captured after the food is being cooked. Both the images are processed, and corresponding histogram and thresholding is done. This is the MATLAB coding, and using this code the readings are stimulated. This figure represents the thermal image and its corresponding normal image. This is the grayscale reading of the normal image. The grayscale image of the normal image is converted to its corresponding indexed image. The thermal image is converted to grayscale image. The contour image is obtained for the corresponding thermal image. This is a histogram equalization graph, and this graph indicates the heat distribution of the food item before it is cooked. This is the thresholding graph, and this represents the stage at which the food is being cooked. This is the thermal image of the food item that is taken after it is cooked, and the corresponding normal image is shown. The corresponding normal image is converted to its grayscale image. This is the indexed image of the normal image. The thermal image of the food that is being cooked is converted into its respective corresponding grayscale image. The contour image of the second thermal image is obtained as shown. This is a histogram equalization graph for the thermal image after the food is being cooked. This represents a equal distribution of heat over the food item. This is a thresholding image, and this represents the stage at which the food is being cooked, which is represented by the white area. These two represents the histogram equalization graph. The first image represents the thermal image which is taken from the half cooked food item, and the second graph represents the thermal image that is taken from fully cooked item. The first image depicts that the heat distribution is uneven and the food is half cooked, whereas the second image represents the overall distribution of heat is equally spread over the food item. These are the thresholding output of the two corresponding thermal images. The first thresholding graph represents that the food is half cooked. The white area here represents the food item, whereas the second graph represents that the food is evenly cooked and it is spread all over because of the increase in heat distribution. Thus, we have analyzed the obtained thermal images. In future, in spite of capturing the thermal images by visual IR camera, we can use an IoT technique. Using that IoT technique, the thermal images are directly sent to any electronic items like mobile phone, PC, etc. Thank you, viewers.